So, in the last lecture, we looked at community interactions, or the way that different species could interact with one another, which remember is interspecific interactions. This time, we're going to be looking at structures within the community. So, that's going to be things like keystone species, foundation species, and then we're going to be talking about species richness and relative abundance, which are statistics, but I don't want to scare you away. It's not that big of a deal. And we're going to use spreadsheeting software to do most of that for us. So let's go ahead and get into it. So when we're thinking about architecturally, what is a keystone and what is a foundation? The keystone is a stone at the top of the arch that kind of keeps everything together. And so keystone species in ecology is kind of a similar concept, and we'll see what I mean by that. And we have a foundation species, which is a species upon which everything else is going to sit. So if you remove a keystone species from an environment, that environment is going to change significantly. If you move a foundation species from an environment, maybe that environment won't exist at all anymore. So let's talk about what is a keystone species and what do I mean by a keystone species. So here is an otter and here is a sea star. So the otter is going to spend its time eating sea urchins and making it so that the kelp forests that it lives in can continue to exist. And similarly, remove these sea stars from their environment, the number of mussels that live there increase, which basically those mussels are going to eat everything up and it's going to significantly decrease biodiversity. So again, let's go back to that figure. If you get rid of this keystone, the arch can potentially collapse, or ecologically speaking, the environment is going to be altered completely if you remove a keystone species. So on to foundation species. Here on the left is a bunch of kelp. This is a kelp forest. And on the right, these are corals, which make up the gorgeous, incredibly biodiverse coral reef. So foundation species are species in which other things live. And it's not even necessarily in which other things live, but if you remove a foundation species, that particular environment is not going to be there anymore. So if you get rid of coral, all of these species that rely and depend on the things that live inside the coral reef are going to be gone. If you get rid of this kelp, the things that live inside the kelp are going to be gone. And so the things that rely on the things that live inside those kelp are going to be gone. So foundation species are basically the foundation upon which entire ecosystems, entire environments rely. So we just talked about keystone species and foundation species, a couple ideas to have in your head. So I might ask you a question like, hypothetically, you're on an alien planet and you find a species and you accidentally remove it and everything in that environment gets changed. What kind of species was that? This is a keystone species. And I'll have probably something similar for foundation species. So be on the lookout for those kinds of questions here. The next idea is this idea of community structure, or how can we describe the actual structure within a community? And one way that we can do that is utilizing numbers, and one of those numbers is the idea of species richness. Now, species richness just tells you the number of species that are in a particular habitat. I've said area here because it's going to depend on what you're studying. So this could be ecosystem, this could be environment, but it's going to tell you about the number of species in a particular place. So let's say, for instance, I find in this environment there are these 3 trees. We have like a bunch of birch trees, which are gorgeous, and then my favorite tree, which is Metasequoia glyptostroboides. And then let's say you have Atlas cedars. So what would be, and you've went through this forest, you've went through this little area, and you've discovered that these are the 3 kinds of trees that exist here. What would the species richness be in this area? And, hypothetically, the only thing that lives here is trees, which is preposterous. But anyway, what would the species richness be? Well, it would be 3, because 3 different kinds of species live here. Now, this is a really interesting and useful statistic, but it can be problematic. Because what if we just looked at how many of each kind of tree there are? If it's 96% birch and you only find one Jeffrey pine and only find one metasequoia, is this a particularly diverse area? And the answer is no, not really. And so species richness can be useful, but you kind of need more than that to describe the actual structure within a community. And so what you're seeing here is the relative abundance. It's 96% birch, 2% Jeffrey pine, 2% metasequoia. This is just another picture using a bunch of random species. And this is showing you the relative abundances of these species through time. This might be a little bit much actually, but it's just showing you, it's giving you an extra perspective on the actual diversity within a region, or within a community, I should say. For example, let's say, you guys are many of you are going to be applying to four-year schools soon, and you want to know about who goes to that school. And I say, oh, there are 10 different kinds of people at this school. Is that a useful statistic? Well, perhaps, but what if 98% of the student population is white? Is it useful to know that there are 10 different kinds of people if 98% of them are white? Is that a diverse campus? Perhaps, but you generally need a little bit more information than just species richness, which again, that's where this relative abundance statistic comes in. So next, or at least one of our next lectures, in one of our next lectures, we're going to be talking about Simpson's Index of Diversity. This is kind of a scary looking formula, but I'm going to show you guys how to make Excel or Sheets or whatever spreadsheet program you prefer do this work for you. And Simpson's Index is going to give us yet another piece of information about the structure of our community. And we're going to learn a few more statistics along with that too. So that's next time.